we've got another ellipse to draw here, and first things first, you always want to have the standard form equation to look at. It's going to make things a lot easier to describe this ellipse. So first thing I'm going to do is rearrange the equation I'm given into a more helpful form. And what I like to do is start off with my x's over here, 4x squared plus 16x, and now I've got my y's to look at. I've got 25y squared minus 200y, and I'm just going to move that pesky 316 over to the right side, negative 316 over here. And now let's do some GCFs. It's not the only way to do it, but I find this helpful as I think through it. You've got 4 factored out, that leaves 4x squared plus 4x inside. And you've got a 25 factored out from this one. And what that leaves behind is y squared minus, what is this, 8y? I think it's going to be 8y. Okay, negative 316. And I'm leaving some space there at the end of those parentheses because what I want to do is do something called completing the square. Well, if you imagine what kind of a perfect square would lead to x squared plus 4x, you get x plus 2 squared, right? Except what else would you have into that? You see you'd have something else introduced by this plus 2 squared right there. You're going to have a plus 4. So we have to keep track of that by adding it to both sides. Okay, and let's do the same for the next one. What kind of square would we have for the y's? Well, that would be 25 on the outside, and this is going to require a y minus 4 squared in order to get that minus 8y. But what's going to happen when you do that? You're going to get, let's see, a plus 16 for this one. And you have to add it to both sides to keep everything balanced. So we've got a 25 times 16 on the right side. And when you add these numbers together, when you add your negative 316 plus your 4 times 4 plus your 25 times 16, you're going to get 100. That works out nice. It doesn't always, but in this case, we're all friends here. We're going to keep things nice with integers. Now what I need to do is divide 100 by 100 because I want 1, like the number 1 on the right side. So I'm going to divide everything by 100 so I can cancel this part out and turn that into a 1. Okay, that's my goal. Now as I simplify the rest of these are not bad. This is really nice. I get x plus 2 squared over 4 over 100 is the same as 1 over 25. And then 25 over 100, well, that's just 1 over 4. So we get a 4 right there. And 100 over 100 is just 1. So this right here is a really nice way of talking about ellipse equations because it tells us so much about what's going on in our picture. And you can just take this and consider this your standard form, right? That is your answer to this first part, your standard form of the equation. Well, I want to point out some things. This value right here, this is called a squared. This value right here, this is called b squared. Typically, we just put a with x and b with y. And what you notice is that a squared is greater than b squared. Well, that means we're dealing with a horizontal ellipse. In other words, like this picture, it goes further in the x direction than it does in the y direction. And that's very, very helpful because without knowing that, I wouldn't know whether my vertices are to the left and right of the center, or maybe they would be up and down from the center, right? And likewise for the foci. So that's a very important point to note at the beginning of this. So the center is located according to these little guys, right? My h and my k values. Remember to flip the signs around because your standard form equation has x minus h and y minus k. So the center is going to be located at negative 2, positive 4, right there. Now my vertices, according to this diagram, because I have a horizontal ellipse, the vertices are to the left and right of the center by the amount a. Now, in our case, remember, a squared is 25. So that means a is equal to 5. So I'm going 5 left and 5 right. So 5 left from the center gets me to negative 7, 4. And 5 right from the center gets me to 3, 4. Okay, so that's pretty easy. The co-vertices they're like vertices, but, in the short direction. So these are going to be going up and down in this case by the quantity b. Now, we know that b squared from that formula is 4. So that means b is equal to 2. So they're going up and down by 2 from the center. So that's going to be negative 2 comma 6 and negative 2 comma 2 from the looks of it. And now where are the foci located? Well, the foci, and this is sometimes a hard equation for people to remember, c squared is equal to the absolute value of a squared minus b squared. Okay? And that equation, you can use that for both horizontal and vertical ellipses, because this absolute value symbol right there takes care of the case when a is greater than b and when b is greater than a. It's going to give you a positive number in both cases. So for us, we get the absolute value of, let's see, 25 minus 4, okay, which is, ew, gross. Okay, that's going to be radical 21, something like that. So, fine. C is going to be equal to the square root of 21. Well, not everything's a nice number, so let's just deal with that. The foci, remember, are located left and right because this is a horizontal ellipse. So you go left and right from the center by square root of 21. So the first one is going to be negative 2 minus the square root of 21, comma 4. And the second one is going to go to the right. So it's negative 2, there's no comma there. It's negative 2 plus the square root of 21, comma 4. Okay? And the eccentricity, it's a weird one. This is basically, let me write you a formula here. The eccentricity is the, it's the length from the center to one of the foci divided by the semi-major axis. Basically, this is a measure of how elliptical your ellipse is. So for us, from the center to the focus, that's that radical 21. And the semi-major axis, that was in the x direction. That was, remember that was this, 25 was a squared, so this is going to be 5. So there's our eccentricity. It's square root of 21 over 5. Okay, now let's see. Anything else to deal with here? We've got to plot this guy. So what do we get for our plots? Well, you just take all your stuff from earlier and put that on here. So I like to mark my center first. That really helps me get grounded. This is negative 2 comma 4. So there's the center, and through it goes the semi-major axis going 5 left and 5 right. We already talked about this one. So is that 5? Yeah, negative 7. Okay. Why is this not working right? Oh, negative 2 comma 4. Oh, yeah. All right. I learned how to plot coordinates better. Negative 2 comma 4 is up here. So 5 to the left and 5 to the right. 1, 2, 3, 4, 5. There we go. There's my semi-major axis. And my semi-minor axis, that goes 2 up and 2 down. So that's going to look more like this. And personally, I just like to put some dots on here to really make it very clear where those vertices are and the co-vertices, like so. And you see these, what I've just drawn checks off A and B of this homework problem. I want the points of the vertices and co-vertices, the segments of the major and minor axes, and the ellipse itself. So it's easier to draw with this nice little handy tool down here for ellipses. Okay, this guy. It's actually pretty neat. And that's it. That's how we draw a horizontal ellipse.